what we would do is we would just finish these identities on page 6 so you had something else to look at in your book, as well as there are some examples in the textbook, right? I mentioned yesterday. If you're still struggling a bit with identities, they go through all the stuff that we have to know in the textbook as well, and I outlined that at I think page 202 or 198 to 200. All right, we stopped here, proving and verifying. Page 5, it said, prove the following identities, identify any non-permissibles. And I stopped here just because they were starting to get a little complicated and we had just started identities and I didn't want to overwhelm you. Now that we have some identity work under our belt, let's take a look at what we have here. So here's our next identity, cosecant times cos squared plus sine. All of that somehow equals cosecant. So how are we going to make the left hand prove that the left hand equals the right hand? What's your thinking here? Any idea? What side would you naturally probably start with? The left, correct? Right, D? Because there's so much to work with. There's nothing to work with on the right, correct? Okay. So what would you do? Cosecant, cos squared plus sine. To 1 over sine? I think so too. I think that's a good move. What do you think, Joanna? So the first thing we'll start with the left-hand side, and Adam says, okay, leave the cos squared, but convert the cosecant to a sine. I think that's a good move. Almost, I would say in the majority of the cases, your first step makes the identity look worse or more difficult or more complicated. Usually your first step makes things bigger, or you're kind of doing some, here we added a fraction, right? You wouldn't think that would be helpful, but that's actually really helpful because now with fractions I can combine, if terms are in fractions, I can combine them into one using an LCD, right? I can't combine these at all. There's no like terms, but as soon as I create fractions, I might be able to do something, right? What is your next step here, do you think? Yeah, so I need an LCD, right, Eileen? My LCD would be sine. Okay, so as soon as I see that, because right now sine is just sitting on top of 1. So if I do this now, I've got cos squared x over sine x. Then I'll have, if I want to multiply the bottom by sine, I multiply it by the top by sine, and guess what I get? Okay, have your eyes become accustomed to what's happening here now? Cos squared plus sine squared is 1, right? So I get 1 over sine x. And I could say that my right-hand side is, it started with cosecant x, right? Well, that's 1 over sine x too. So left-hand side equals right-hand side. Done.
I have a question. Cos squared plus sine squared is 1.
Cos squared plus sine squared is 1. Yeah. Look on your formula sheet, the very first identity you see there. Let's do our non-permissible values. Do you see any non-permissible values here? I have one denominator, so sine of x can't equal 0, right? Let's do, I'm going to make a little ruling here. Let's do the NPVs for, let's do for 0 just, I guess it's not theta, it's x. Let's just do from 0 to 2 pi, or 0, I'll just say 2 pi again, but I'll say it's either x or theta, because some of these have x's, some of them have thetas. So for these 4 identities, let's just use one rotation to identify our non-permissibles. So for this non-permissible, sine x can't equal 0. Where does that happen? Where does sine equal 0? 0, pi, and I'm not going to include 2 pi because it wasn't included in my search area. Okay? We okay with that? Neville, I did a handout at the beginning, so you'll have to come grab one later, and then we're just doing these last examples on page 6. Okay, what about this next one? Cotan cubed equals cotan times cosecant squared minus cotan. What side would you start with? They both look strange, right? Uh-huh. There's stuff to do, right? What would you do on the right side? I don't think I can do subtracting because they're not like terms. Rahel, what was that? What did you and I talk about? What's something you should always think about doing? Factoring, right? Can we factor anything here? Yeah, they have a GCF of cotan, right? So if I factor out cotan, what do I get? Cos squared minus 1. Okay, I always have my formula sheet in front of me all the time, even now, and I've taught this for years and years and years. So I kind of look at my formula sheet to guide me too.
How about if we isolate that over the left side?
Pardon me?
If we isolated copy it out over the other side,
You could start with the left side if you wanted to. Yeah, you could do that. You could start with the left too, if you wanted to. Yeah. So what does this? Anytime I see squares, I kind of go to my Pythagorean. Does this equal anything? Let's look. This is let's look at our third Pythagorean identity. 1 plus cotan is cosecant. Remember I said there's 2 other ways to write these guys? Let's see, what's another way to write this? If I move the 1 over, what do I get? Cotan equals cosecant minus 1, which is exactly what I have, right? So cosecant squared minus 1 equals cotan. So I can substitute that identity in here. So I have cotan times cotan squared, which is cotan cubed, right? Right-hand side equals left-hand side. Now you could have started here and broke it into a cotan times cotan squared, and then substituted this for cotan squared. Kind of the same thing, but backwards. What are your non-permissible values this time? Okay, are there any, let's see, all of these are reciprocal functions, right? May have a bottom, so this is sine, or cos over sine, this is 1 over sine over, so it's just sine again, right? Sine of theta can't equal 0, so again it's my same answer, except I'm using theta instead of x. Okay, what about G? Cos of x times sine of x all over 1 plus sine equals 1 minus sine over cotan. This is a little trickier, right? There's not a clear-cut winner and who's most difficult. They kind of look similar. You can work both sides? Okay. What side should I start working with? Or do you want me to start working with? The left? Okay. What do we want to do on the left-hand side? Anything? They're already in sines and coses, right? This is the left-hand side? Okay, so I've got cos of x, sine of x, all over 1 plus sine x. And this is the only piece that has a conjugate, right, John? So I'd multiply by 1 minus sine, 1 minus sine. Okay? So the conjugate is just the second factor in a difference of squares term, right? Because you're creating a difference of squares. Why can I multiply by the conjugate over itself? Why can I do that? Why is that allowed in identity work? I'm just multiplying by 1, right? So I'm not changing anything. So let's see what happens. What will happen on the bottom always when I multiply by these two factors. I'll always get a difference of squares on the bottom, right? So my bottom's going to become 1 minus sine squared, which is great because that's a Pythagorean identity. I'm going to leave, unless, now this is really important. I want to create the difference of squares so I can use my Pythagorean. But for these guys, I'm just going to keep it in this form, right? I don't really know what's happening yet. So I'm going to leave it in factored form because a lot of times I need that form to cancel things out with. So it's cos times sine times 1 minus sine. Okay, now what? Why do we want to create difference of squares? Why is that so important? Like, why was it so important for me to take this 1 plus sine and create a 1 minus sine squared out of it? Because then I can go to my formula sheet, right? Remember, these guys too have alternate forms. Sine squared equals 1 minus cos squared. And cos squared equals 1 minus sine squared. In case I needed that. Okay, so if I replace this with cos squared, I think that might help me, right, Joanna? Okay, so I have cos x sine x times 1 minus sine. I don't technically need these guys in brackets because they're just being multiplied. They're not added or subtracted, all over cos squared. One of the other reasons, so the only reason I multiplied these two was because I was creating the difference of squares to use that identity. I rarely multiply the top three. You want to leave it in factored form because you're going to be canceling. Also, one of the other reasons is, notice this 1 minus sine is part of my goal, right? I want to keep the 1 minus sine because it appears on the right-hand side. I'm trying to make the left-hand side equal the right-hand side. As soon as I get this 1 minus sine, I say, well, I want to keep that, right? Now what's going to happen? I've got a cos, 2 on the bottom, 1 on the top, correct?
Yes.
So that is what? Sine of x over cos of x times 1 minus sine, which is, what is sine over cos? It's tan, right? So then I have tan x 1 minus sine. And I mean, I could convert this to cotan, or I could say this is what I had on my right-hand side. I could choose to do this because I'm running out of space here. If I move this up to the top, what does he become? 10. And there we go. Left-hand side equals right-hand side. Sorry? 1, 2, 3 here. Yeah, everything's over cos squared. I could do this too. But what I chose to do, this is being multiplied, right? I just, because it's multiplication, it's not addition. It's multiplication. I could break these apart and say this is sine over cos times 1 minus sine over 1. Like that. It's multiplication, it's not addition. I couldn't do that. If there was a plus sign here, I couldn't do that. They both would have a cos on the bottom. Okay, how about this? Think of it this way. Okay, look at this. Right now I have sine over cos x, right? 1 minus sine x. Agreed? That's what we had? Correct? Okay. So what if I move him upstairs? What does he become upstairs? Secant? So I could have secant x sine x times 1 minus sine x, right? Okay, so then how about I move him downstairs? He becomes cosecant, right? Do you agree with everything I've done so far? Okay, whether I put this here or just leave it like this, it means the same thing. Okay, and secant over cosecant is what's secant over cosecant? 1 over cos, 1 over sine, right? 1 over cos times sine over cos. It's just tan, right? So again, this becomes my tan on top, or my cotan on the bottom, right? Like it just, I think you're getting this mixed up with a plus sign. But this, the whole bar here, it doesn't matter whether the whole bar becomes only here or all the way across for this question, because it's multiplication and division. Because multiplication, division, order doesn't matter. No? Okay, what would the non-permissibles here be? Non-permissible values? Okay, what do we have? We have a cotan. So cotan can't equal 0, right? Well, when does that happen? It also happens, cotan is cos over sine, right? So sine can't equal 0, right? These are the same. What else do we have to worry about? Cos is okay, sine is okay. Cotan I've got here, it's just where sine equals 0. What about this one? 1 plus sine also can't equal 0. Agreed? Okay, so where does sine equal 0 from 0 to 2 pi? That's my 0 and my pi, correct? Same as we had in A and B, or 1 and 2. And what about this one? So that means sine of x can't equal -1, so x also can't equal 3 pi on 2. Right? So these are my non-permissibles this time. Okay, last one before I let you go for break. What about this guy? Sine plus cotan over secant equals cosecant. I think everyone would agree we're going to start with left-hand side. Agreed? So what is your thought process before you even think of any identities you're going to substitute? What's your thought process? What do your eyes see from the left to the right? Just even, what's the most obvious thing that your eyes see from left hand to right hand? You see fractions here, and what do you see here? How many terms do you see here? Just one single simple term, right? It's a reciprocal. I see signs here as well, right? My head's thinking sine. But basically, I hope what you're thinking is I've got to take two terms, mush them into one, and then probably do some canceling. What's the only way you can take two terms, if they're not like terms, and these aren't? The only way you can take two terms into one is LCDs, right? So, or some kind of fraction work. So see what you can do, and there's lots of ways you can approach it. See what you can do to push these two guys together. anyone got the identity worked through? Okay, before we create, Mohamed's going to show his method for the identity. I'm curious to see if people, there's always more than one way to do it, so I'm curious if there's other strategies too. He started with the left-hand side. Let me know if you did it that way too. Nice. See that? Okay. So how many people did it like this? Can you see? Did anyone do it differently? So first thing he did was, how did it start off again? It was a cotan, right? Cotan over secant. So it was cotan over secant sine x. So I think the first thing he did was he just said everything's going to sines and coses, right? That's what you did. So he just converted this to cos over sine, and this is 1 over cos, but he wrote it in this form because he's going to end up multiplying it anyway. Then he did his cos over sine times cos over 1, right? That gives him his cos squared. As soon as you get the cos squared, that kind of rings those bells, right? If I'm going to combine my two fractions, LCD is sine, that gives me my sine squared cos squared, which is beautiful. See how many of them come back to that key identity? Sine squared plus cos squared is 1. You get your sine squared cos squared equals 1, and then you're home free, right? 1 over sine is cosecant. So nice way of doing that. Anyone else do a different strategy? What did you do, Eileen?
First of all, I put secant first, and then
So you did sine. Oh, you left it as cotan? Yeah. Yeah, you end up the same thing. Eileen started, she just left it as a secant. Oops, I forgot a plus sign, didn't I? Okay, I think that's the way I was going to go too. Eileen left it as a secant and combined them with secant as the LCD, then later flipped it up to cos, became a cos squared, right? You kind of end up the same way midway through. She just started with a secant as the LCD, right? Perfect. Okay, go take a break. Work on that, and then come back in about 5 minutes. And I want to introduce the sum difference.